Hello, everyone. Thank you for coming to class. I am Dr. Prato. This is Algebra 1, and today I'd like to talk to you about the fundamental counting principle. So let me begin this with an example. Imagine that you are currently in city A and you would like to travel to city B and then from city B to city C. Now let's imagine there's three ways that you can go from city A to city B. Just for fun, we could say those are you could take a car, or you could take a plane, or you could take a train, just for fun. And now imagine there's only two ways to travel from city B to city C. Let's say here you can either take a boat or you have to take a plane. Now, let's think, how many ways can we travel from city A to city B? Well, you could do car, boat, car, plane, plane, boat, plane, plane, train, boat, train, plane. Now, how many ways is that? Well, that's one, two, three, four, five, six. Now, is there an easier way that we can remind ourselves or do these types of problems? Well, yes, it's called the fundamental counting principle, which states that the number of ways an event can occur is found by multiplying the number of choices we have each step along the way. So in this example, there was actually only two places where we need to make a decision. We had to choose how we were going to go from city A to city B, and there were three ways that we could have done that, and how we go from city B to city C. And here, there's only two ways. So again, the fundamental counting principle states that the number of ways an event can occur is found by multiplying uh, the number of options you have each step along the way. So 3 times 2 is equal to 6. Let's do another example. Let's say that a restaurant offers 9 appetizers, 15 main courses, 5 desserts. And how many ways can a person order a 3-course meal? Well, let's think, how many where are the choices that we're going to make? Well, we have to choose an appetizer, we have to choose a main course, we have to choose a dessert. So that sounds like there's going to be three places where we will have to make a decision. It says that there are 9 appetizers, there's 15 main courses. I'm sorry, that looks messy, and I'm sorry, that's still a little messy, and 5 desserts. So if we use our calculators, let's see what happens. What's 9 times 15 times 5? 675. So that's 675. So what does that number mean? That means that you could have 675 unique uh, meals. One, selecting one appetizer, one main course, and one dessert. So maybe an appetizer is like salad, and then main course is like chicken, and then chocolate cake. Would that be fun? Okay, let's move on to the second, our next example. Here it says that a multiple choice test comes with 25 questions and 4 choices for each question. Which one with one correct answer? Assume you do not leave any questions blank, and how many ways can you answer each question? Well, let's think. If there's 25 questions, that means we have to make a choice for the first question. And how many choices are we going to have? We're going to have 4 of them. And we have to do this, the second question. How many choices do we have? We have 4 of them. We come to the third question. How many choices do we have for the third question? It's 4. All the way down to the 25th question, which we also have 4 choices. So what's 4 times 4 times 4 times 4, 25 times? Well, we can write that as 4 to the 25th power. And this is an incredibly big number. Um, in the class, in my class, you can leave it just like that. We'll see if my calculator can even do this. It's obviously there's more digits that we're not seeing. Um, I much prefer saying this is 4 to 25th. So the probability, remember the last class we had on probability? The probability that you would get the right answer just by guessing would be 1 over 4 to the 25th power, right? Very small. Let's talk about this next question. It says, you are helping out at a Sunday school to earn service hours. There are 11 students in class today. You need to walk with the students in a line. One girl insists on being first, and one little boy insists on being last. If your requests, if their requests are granted, in how many different ways could you order the students? Well, let's think. There's 11 students. So I'm going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes. Now, it says here that one student wants to be first. So there's only one, and if we're going to grant their request, there's only one person we can put in that first box. So that's not even a choice. We have to have one person. We have to have that specific one person there, and another person wants to be the last in line. So we started off with 11 students. We took, one of them wants to be in first. Now we only have 10 left. One of them wants to be last. Now we only have 9 left. So the and the places that we can make a choice, we can either we can let 9 students, we can pick one of the 9 remaining students to be in the second to last place. 8, 7, 6, 5, 4, 3, 2, 1. So imagine if we just had 11 students, and we were lining them up in a row. Well, that'd be 11 times. We don't care about the order, right? It'd be 11 times 10 times 9 times 8, all the way down. But in this situation, it's a little different because we have to have one specific person in the first place and another specific person in the last place. But all the other places are up for grabs. And of those 9 other students, any one of those 9 could go here. Now we only have 8 left. Any one of the other 8 could go here, so on and so forth. So let's use our calculator and see what it says. We do 1 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you don't have to do this, but we'll put times 1 again for the, 1 times 1 times 1 is always 1. This says that there are 362,880 different ways we can line up the students. What I want everyone to do now is to work on the next 3 problems in your worksheet, and I'll come around and help. And we can start we'll pick up the lecture in a little bit. Thank you so much for coming.